Hello, welcome to the recording of the NSECE webinar comparing the 2012 and 2019 NSECE listed home-based providers. This webinar was originally streamed on April 27, 2021. It was the first in a three-part series on making comparisons across the NSECE survey rounds. Before we begin, we'll first provide an overview of the NSECE. The National Survey of Early Care and Education, otherwise known as the NSECE, is sponsored by the Office of Planning, Research and Evaluation, also known as OPRE, and the Administration for Children and Families in the U.S. Department of Health and Human Services. The OPRE team includes Ivelisse Martinez-Beck, Ann Rivera, Bonnie McIntosh, and Ellen Lukowski. The project team is led by NORC at the University of Chicago, but since 2007, partners have included Child Trends, Chapin Hall, and many other excellent independent researchers. The purpose of the NSECE is to provide information on early care and education services available to families in settings that are home-based for children under age 13 and center-based for children ages birth through age 5 not yet in kindergarten, as well as characteristics of the workforce providing these early care and education services and households with children under age 13. The 2012 NSECE provided much-needed, nationally representative data about early care and education through 4 integrated surveys. These surveys captured the full spectrum of those who use and provide ECE, including center-based providers to children not yet in kindergarten, home-based providers to children under age 13, households with children under age 13, and center-based classroom staff to children not yet in kindergarten. The 2012 NSECE also measured how the availability of care interacted with how families use that care. The 2019 NSECE largely replicates the design of the 2012 NSECE, which allows researchers to achieve all the goals of the 2012 NSECE and also supports measurement of change from 2012 to 2019. There are small differences in sampling and questionnaire contents between 2012 and 2019, and these are documented in the 2019 NSECE User's Guides. And now, let's briefly discuss the key design characteristics and variables in the NSECE. This slide depicts the relationship among the 2 sample sources and the 4 NSECE surveys at the foundation of the NSECE data collection design. The 2 long rectangles on the right and left sides, respectively, represent the 2 NSECE sample sources, the household sample on the left and the provider sample from administrative lists on the right. Each of the rounded boxes in the middle indicates a survey, and the diamond-shaped boxes stand for screening instruments. This webinar will focus on the listed home-based provider survey. On the right of this slide, we have the provider sample, as mentioned. Home-based providers who appeared in the provider sampling frames constructed from state and national lists were sampled for this survey. We hence designated these providers as listed since they were listed in these lists. Listed providers were primarily licensed or regulated family daycare providers, but also included other formally listed home-based providers such as licensed exempt providers or providers participating in Early Head Start. Alternatively, on the left, households could have been identified as eligible based on their responses to the household screener, specifically that an adult in the household regularly cared for children not his or her own at least 5 hours per week in a home-based setting. These providers did not appear in the provider sampling frame and are designated as unlisted, since they were not listed. We will not be discussing unlisted home-based providers in this webinar. All 50 states and the District of Columbia are in the NSECE samples for both the 2012 NSECE and the 2019 NSECE. Our primary sampling units, otherwise known as PSUs, are counties, or clusters of adjacent counties. One distinguishing design characteristic of the 2019 NSECE is that the same PSUs as the 2012 NSECE were used in the sample design of the 2019 PSUs. The intention of this approach was to reduce the variance of the estimate of the difference between 2012 and 2019. The variance of the estimate of the difference between the 2019 and the 2012 estimates is the summation of the variance of estimate from each year minus 2 times the covariance of the 2 years. This means that the variance of the estimate of the difference is minimized when the covariance between the 2012 estimate and the 2019 estimate is the highest. We can achieve this by overlapping the 2012 and 2019 PSUs because repeated measurement of the same PSUs are more likely to be correlated with one another, since any changes between the 2 years is more likely to be due to the changes in the same PSU. Although we use the same PSUs between 2012 and 2019, it is important to highlight that the same providers were not sampled between the 2012 and 2019 NSECE. That is, the NSECE is not a longitudinal survey where the same providers are surveyed over time, but instead a repeated cross-sectional survey. Therefore, the 2012 NSECE and the 2019 NSECE have their own design variables. Each NSECE dataset includes a weight variable and 2 survey design variables, strata and primary sampling unit, or clusters. The design variables are needed to account for the multi-stage stratified cluster sampling used in the NSECE. Because the NSECE has a complex design with oversampling and other features, we strongly recommend that you always use sampling weights when analyzing NSECE data. Analyses without sampling weights represent only those respondents and no broader population. When working with the listed home-based provider quick tabulation data files for the 2012 NSECE and 2019 NSECE, you'll notice that the weights, strata, and primary sampling units variables from the 2012 NSECE start with HB, while all 3 design variables from the 2019 NSECE start with HB9, as depicted in this table. That concludes our overview, and now Ji-Yoon Park will cover how to make comparisons across NSECE survey years.
Today I'm going to describe the 4 steps in doing comparisons across survey years in more detail. Later in the presentation, we'll also provide 2 examples comparing 2012 and 2019 unlisted home-based NSECE survey. The first step in conducting comparison across survey years is to ask, what do we want to compare? And there are 3 sub-questions you want to ask in this step, and we'll go through each in detail. You'd first want to have a clear definition on the measure you want to compare across survey years. For example, are you interested in comparing the number of providers between the 2 years? Or proportion of providers serving certain age groups? When using a survey question to generate the measure, it's important to check the original wording of the survey question and codebook from the NSECE Quick Tabulation Manual for each year. The NSECE manual provides details on the data collection and whether or not the question can be compared directly, need to be compared with caution, and if the direct comparisons are not feasible between the 2 survey years. Secondly, you'd also want to be sure that the samples in each year are defined the same way. For example, if you're comparing characteristics of providers that are open during evenings between the 2 survey years, you want to make sure that the providers were defined in the same way between the 2 survey years. Finally, you also want to examine available resources. The Child Care and Early Education Research Connection has various resources, such as reports and papers, survey instruments, fact sheets, and briefs using NSECE survey. You can read these available resources to find out if there's any existing research studies that are related to your research questions. Once you have completed step 1 and have a clear idea on what you want to compare across the survey years, the next step is to calculate the point estimate and variance of the measure you want to compare for each survey year. Step 2 comprises of 4 important components, and I'll discuss them in more detail. It is very important that when calculating point estimate and variance using NSECE, we use statistical software that has the capability to adjust for complex survey designs. NSECE relies on a complex survey design, and ignoring the design can result in biased estimates. The good news is that major statistical softwares such as R, Stata, and SAS have their own survey-specific functions, procedures, or packages for handling complex survey data. When using these statistical software, it's important to use the correct weight and design variables. The variable names for the weight and design variables between 2012 NSECE and 2019 NSECE are slightly different. For example, the weight variable for 2012 home-based survey is HB method underscore weight, whereas for 2019 home-based survey, it is HB9 underscore method underscore weight. Once you have decided on which statistical software to use and identified the weight and design variables, you'll also have to decide which statistic you're using to do the comparison. Most statistical software has its own command for calculating different statistics, such as the count or weighted total, means, and proportions. After you're decided on the statistic, you'll be easily able to calculate the within-year point estimate and the design-corrected standard errors for each survey year using the appropriate commands. In this step, it is also important to note that there are several methods for estimating standard error. The two major ones are replicate survey weights and Taylor series linearization. Taylor series linearization is also the default method in some statistical software, and you will notice it in the output. And finally, in step 2, it is important to keep track of various components in this step. You will need to keep a record of the within-year estimate, its variance, and unweighted frequency for each survey year, as those ingredients will be required for calculating across-year survey differences and variances in step 3. Once you have completed calculating point and variance estimate for each survey year, the next step will involve calculating across survey year differences and its variance. This step comprises of two components: calculating the difference by subtracting the weighted estimates between the two survey years, and estimating the variance, or standard errors, of the difference in 2012 and 2019 estimates. In order to calculate the across survey year difference, you'll simply need to subtract the weighted 2012 estimates from the weighted 2019 estimates obtained from step 2. Estimating the standard errors of the weighted difference is a little more complex than estimating the weighted difference. The variance of the difference is the sum of the variance for two means that are being compared, and the standard error is the square root of that variance. The details of this step will be provided in a separate technical handout. But at this point, it is important to remember that you will need the within-year standard error and unweighted frequency from step 2. The fourth and the final step is conducting significance tests of the across-year differences. And this final step comprises of 3 components. Firstly, it's important to think about the research question and decide which significance test is being used as part of the hypothesis testing. You can revisit the question in step 1, what are you comparing, and think about which significance test would be most appropriate. You will also need to decide your choice of significance level. 0.05 is a widely used significance level in hypothesis testing. After you've decided on which significance test to perform, you can calculate the test statistic, degree of freedom, and also associated p-value to determine the statistical significance of the difference. This step can be done through manual calculations using appropriate formulas or through statistical software. One of commonly used significance tests in across-year analysis is Welch's unequal variance t-test. This test compares if two populations with unequal variance have equal means. Once you have determined whether or not you find statistical significant differences across two survey years, you'll revisit your null hypothesis and interpret the substantive meaning of the result. Illustrated examples. In this section, we'll go through step 1 through 4 and try to answer two research questions using 2012 and 2019 NSECE listed home-based provider survey. In this example, we'll explore the research question, was there a change in the total number of listed home-based providers between 2012 and 2019? In the second example, we'll try to answer the question, was there a change in the mean number of children cared for by each listed home-based provider between 2012 and 2019? The first step is to ask ourselves what we want to compare. Firstly, the research question requires getting the weighted total of the listed home-based providers between the 2 years. Also, because the weighted total is not based on a specific survey question, you'll need to generate an intermediary variable to represent the count of providers in the dataset. Step 2 is to calculate the point and variance estimate for each survey year. This is samples data code and its output for setting the weight and the design variables for 2019. You will notice that we have specified the weight and the two design variables used in 2019 NSECE survey. After setting the design variables, we generated the count variable, a new variable, to represent the count of providers in the survey. This will enable us to estimate the weighted total of providers. We can use a specific command, survey total, to get the weighted total of the number of providers, now represented by a new variable called count. Notice the number of observations, 4,231. This is the unweighted frequency in the survey. The weighted total of the count variable is also provided in the output. 91,153 is the point estimate of the weighted total of the providers. Its associated standard error and the confidence interval is also provided in the output. Once you have calculated the point and variance estimate for each survey year in step 2, you are now ready to move on to step 3, which is to calculate across survey year differences and the variance. We will need the within year point estimate, standard errors, and unweighted count or the frequency from step 2. These are provided in the first two columns to estimate the across year differences and its variance. To get the across year difference, you can simply subtract 2019 point estimate from 2012 point estimate. The associated standard error of the difference can be obtained by the square root of the sum of the variance for two means that are being compared. The details of the formula will be provided in the technical handout. For those who are interested, you can refer to Welch's Sater-Wade t-test. Now we are ready to move on to significance testing. The null hypothesis in our example would be that the difference in the weighted total of the listed home-based providers between the two survey years is 0. You can get the test statistic by dividing the point estimate of the difference by the standard error of the difference obtained in step 3. You will then apply the Sater-Wade approximation to get the degree of freedom and finally its associated p-value. You see that the p-value is smaller than 0.05. This means that the probability of observing the difference that we are observing from our data when the null hypothesis is true is smaller than 5%. So we can conclude from our significance test that we have enough evidence to reject the null hypothesis that there's no difference in the weighted total of the listed home-based providers between the two survey years. To summarize, the total number of listed home-based providers decreased from 121,000 to 91,000 between 2012 and 2019 survey years. And the results from our significance test suggest that we can reject the null hypothesis that the number of listed home-based providers between the 2 years remain the same. So in our first example, we have established that there was a change in the number of listed home-based providers between 2012 and 2019 survey years. How about the mean number of children cared for by listed home-based providers between the two survey years? We can test this research question by comparing the variable HB_enroll_total from 2012 NSECE with HB9_enroll total from 2019 NSECE. These variables capture the total number of children enrolled for care with the listed home-based providers. You can check the survey questions and the quick tabulation file documentation to see if the question was asked in the same way between the two survey years. Step 2 is to calculate the point and variance estimate for each survey year. And after setting the survey weight and design variables, you can use appropriate commands to estimate the weighted mean. This is again a sample code and output from Stata. And you can see that the weighted mean number of children enrolled in listed home-based providers is 8.6 for 2019 NSECE, and its associated standard error is 0.17. The unweighted frequency for 2019 NSECE is 4,231. It's also very important to note here that when there are missing values in your survey question, that you do not drop these cases from the analysis. Instead of dropping cases with missing values, we advise using subpopulation function to subset or assign a value based on the questionnaire logic. After you have completed step 2, you can now move on to step 3, which is to calculate across years differences and variance. You can calculate the across survey year difference in the weighted mean by subtracting the 2019 estimate from 2012 estimate and calculating the variance or standard errors of the difference using the point estimate standard errors and unweighted frequency obtained from step 2. Now we are ready to move on to a significance test to compare mean of children cared for by each listed home-based providers between 2012 and 2019. The null hypothesis would be that the difference in the mean number of children cared for by each listed home-based provider between 2012 and 2019 is 0. You can get the test statistic by dividing the point estimate of the difference by the standard error of the difference obtained in step 3. You'll then apply the Sater weight approximation to get the degree of freedom, and finally, the associated p-values. You see that the p-value here is greater than 0.05. This means that the probability of observing the difference that we are observing from our data when the null hypothesis is true is greater than 5%. Therefore, in this example, we do not have enough evidence to reject our null hypothesis that the difference between the two survey years is 0. To conclude, we can say that the mean number of children cared for by listed home-based providers in 2012 was 8.3 and 8.7 in 2019. The estimated difference was not statistically different. Combining the results from the two analyses today, we can say that the number of listed home-based providers changed between 2012 and 2019, but the average number of children enrolled in each listed home-based providers did not change. To recap, in doing the comparison across survey years, we have 4 basic steps. First step is to ask ourselves, what do we want to compare? Second step was to calculate the point and variance estimates for each survey year. Step 3 was to calculate across survey year differences and variance. And step 4 was conducting significance tests. And these basic steps can be used for doing comparisons you might want to consider using both 2012 and 2019 NSECE data for a single sample. For more information, you can refer to following websites for downloading NSECE data. And you can also refer to these websites for resources, for NSECE data and tools, for publications using NSECE data, NSECE questionnaires, and resources for planning your analysis. For more questions and suggestions about the NSECE data, you can also reach out to us at nsece@norc.org.